Hello, everyone. It is time to write some unit tests for the integration test that we wrote in the last log. So, yeah, let's just get to it. This guy right here is referenced in the tests. All right. So, we have this unity test, which is different from a unit test. Um, and it's kind of in its own DLL. And what's interesting about this is it runs in play mode, and but we want a test that these tests are really slow, so we want really fast tests to test on variations or what's considered zombies from James Grenning, 0, 1, many, boundaries, interfaces, exceptions, and special cases. So we're gonna kind of go through, figure out the different, how we might do this same test, but just testing the variations. Like for example, if the target is empty right now, then we essentially won't have a way to it'll just throw an exception because it'll try and warp to an empty target because it's checking against the distance. There's no code guarding against that situation, right? So we probably need a guard clause here, but we want to write the tests. We're doing test-driven development, so we want to do the test that will cause us to do that. One thing I noticed, got to rename this file since it was just an old file that I was reusing. And we're going to kind of create some unit tests in here. So I'm going to go ahead and create a new file. It's going to be that.cs. Let's see, and we're going to just call this one, actually, we should probably name it. We should name both of these based off of the name of the class we ended up creating. So, yeah. And, yeah, so that's good. We're going to go ahead and create a new file here. tests.cs, bam. And inside that file, we're just going to kind of have this same layout here. Close some curlies, and I think we're kind of on the right track here. So this is not really bound to the DLL yet, and that's because Unity hasn't seen this file yet. So I kind of, whenever I create a file outside the editor, go back into the editor so it can recompile, detect all the scripts, and put it back into the project. And we'll see that. And here we go. So then we can kind of figure out what we want our test to be doing. Whoops. Yeah, we don't want it to be named that. So we want something in this, and we're gonna call it something like maybe unit tests because this is not an integration test. So maybe just one more time rename the file so we can keep that. Yeah, I'm doing a lot of renaming. I just want to keep everything clean. But yeah, you might work this out after the fact. Okay, so we're just going to assert fail just to make sure that this is getting caught by your unit tests. And we'll see that in the test runner pretty soon here. And so this is our play mode test. We can run that just to kind of see that the project's still working. And this is a little bit of what I was talking about with how long they take. But if you had many of these, which we will build up kind of a suite of them over time, you might, these will obviously run a little bit faster because they'll hit, there's some setup and teardown. But these, on the other hand, bam, already done. We have our new test there, shows it to us right away. We can open the error line, and there it is, right? What we want to do is we want to prove whether or not this fails when we don't have a target. And that will be kind of the first thing that we want to make sure, just in case our targeting system will return back a null, right? So this is what I'm super excited about with unit testing in Unity now. Creating new game objects does no longer makes the test fail. So player equals new game objects. Actually, we'll even just say enemy because we don't have a player, right? We don't even need the player. Equals new game object. And dot add component, right? And because we're in a unit test, there's no update loop and there's no concept of the, so for our arrange act assert, our act usually before was wait for the update loop. But now we can't do that, but we can just call update and it will do the same thing. And so, but that requires us to expose it publicly or call it through reflection. I prefer to expose these publicly, especially since this kind of weird deal where Unity's calling private members kind of confuses people. So now, oh sorry, yeah, we need the warp var warp equals that. So now we can call the update function on warp. So that's our arrange, that's our act. And we, would get an exception. So, it's like assert pass. And we get here when there's no let's see. Actually, the idea here with our update is that, it doesn't fail. No failure with no target. So this is our kind of zero case. So we'll try that. I expect that to fail because our code right now is trying to check the distance on an empty object. Run it all, and bam. Failure, null reference exception, kind of exactly what we were expecting. We can actually go to the error line, and yeah, on our distance check here, it blows up because our target is empty. So just to make that pass, I think we can just say if, let's see, target is null. Okay. Right, so don't do anything if we're in a situation where we don't have a target because we're not trying to catch up to that target, so we can just kind of wait around. It's okay. Check if our test run. Bam. Check if our play mode test runs. And I feel pretty confident about that. So that looks pretty good. So, kind of with the test-driven development thing, we kind of want to find tests that we expect would be, interesting or triangulatable. One thing I'm interested in here is that on enable, we're causing a nav mesh agent to get created. I don't know what happens in the unit test when you call warp to a target. So it'd be pretty interesting just to see if this will actually work in the unit test. Otherwise, we're going to have to do some, some sort of injection to make sure that we can replace the warp call. But I'm just going to try it kind of full stack and see what it does. And then, yeah, if it doesn't work out, then we'll just spy on it in the end. So next bit, I'm going to create a new test. Oh, and actually we should rename this test to update does not fail when no target. with no target, right? So great. We got our test. We're going to just duplicate that. We're going to just not worry about the name of this test right now. And we have an enemy. We have the warp. And then we also want player this time. Player equals new player, new game object. And we are going to just explicitly set the target. Warp.target equals .transform. So now it's not null anymore. I would run this right now and I would expect it to fail because the update will cause it to look for a nav mesh agent that doesn't exist. But let's go ahead and just try it here. Excuse me. So we will run all again once it finishes detecting changes, unless we have an error, which we do. So that'll take us there. Test foo. Oh, curlies are off. Darn those curlies. All right, we gotcha. All right, run all. Who passed? No failure with no target. All right, so what does that mean? That means for us, yep, we had a target. I don't believe on enable got called, which then means, oh, because our distance wasn't high enough. Hey, that's great. So actually that's a good thing anyway, because we want that test. So I'm just going to capture that with a better name. And so let's explicitly set their distance. So player.transform.position equals new 3 0, 50. And then enemy.transform.position equals new vector 3 5 4 0 53. So that'll be well within the distance. And so this is going to be and in fact we're going to assert r equal, and then we're going to just call this like original position. Original player position, and we're going to grab this one, and we're going to say original enemy position, and we're going to say player.transform.position, comma, original player position. And then we're going to do the same thing for the enemy position. Original enemy position. Okay, so what we're doing here is we're taking the player, we're moving them to the 50 space, we're kind of moving them a little bit apart from each other so that they're not overlapping and that it's not bounded to the 0, 0, 0 location. And we are proving that that they don't move, right? Because we're too close, so it shouldn't warp us, right? So great test to write. Run all, and bam, passing. So we're going to rename that one to enemy should not warp when close to player. Now let's maybe write that other test that we had thought about. So again, foo. Now we're going to move them much farther away from each other. So 153 The warp location is 50, so this should be way far away from each other. And yeah, so basically we want to make sure that the enemy transform is not equal, and assert dot less or equal to, and then we're going to do a vector3 dot distance of enemy dot transform dot position player dot transform dot position. So and then comma, and then we want them to be within 50, right? So what we're saying is the player's position did not move, the enemy's position did move, and now we are within the distance that we expected. So yep, so let's go ahead and give it a shot. This should call warp. I think warp will throw an exception maybe in here, but we can just take a look and see what that looks like. Yep. So null reference exception, and that's because our warp object is not populated. This nav mesh agent, sorry, is not populated. I'm going to try calling on enable just to see what happens because I'm curious. But we're just going to, see. So warp dot on enable. So what that'll do is it will make sure that it gets a component off of it. Oh, and of course that component's going to be empty. So our enemy also needs a nav mesh on him. So we're going to just say var nav mesh agent equals enemy dot add component nav mesh agent. Okay, but we need AI in here. So bam, it's already available to us. Great. So we're adding the component on it. All right, let's give it a shot. Wow. Okay, so I'm gonna break the production code just to see. It must have called warp and not had an exception. This would be fantastic because, yeah, our integration test tests whether or not warp gets called at all, and that would fail if I took warp out. And our unit test, and so it must have moved the positions it must have moved the transform position even though we didn't have a nav mesh associated to it. Okay, so the way that we might break this code is by commenting this line out, because then we would have never moved to that location, right? So let's just run that test again. Oh my gosh, that is awesome. Hey, who knew? So easy. And we'll try it one more time. Passing. All right, let's give it a good name. This is really exciting. Like this type of testing was impossible not too long ago. So it says enemy should teleport close to player when distance exceeded. Alrighty. Well, I'm pretty satisfied with that for this video. Please share with somebody having quality problems inside of Unity, or just trying to figure out a good way to test. You no longer need the humble object pattern to do unit testing, integration style unit testing. So Detroit and not London style unit testing inside Unity. That's fantastic news. These tests become so much easier to write, so I definitely recommend it. So share far and wide, write comments if you have any questions, and I'll catch you next time. Thank you very much.